is the Chief Technology Officer at Salesforce.com, where he designed and built many aspects of the multi-tenant software as a service development platform. Areas of database scalability are areas of his expertise, including a flexible customer data model, the application metadata layer, the row-level sharing model, and the multi-tenant query optimizer. Craig's focus on the Force.com development platform includes designing and authoring the Apex citizen programming language, as well as the application distribution model. Craig has a bachelor's in applied mathematics and a master's in computer science from Harvard. So without further ado, this is Craig Weissman.
So we're a small group tonight, so I encourage you to just ask questions. This presentation covers a pretty big, wide range of technology, introduces the company a little bit for those of you who are sort of curious who's familiar with what the product is. I'll start there. But we're going to go into lots of different things. It's called Scaling for the Cloud Scalability, but really it's all about sort of functional scalability, which is Salesforce does a lot, but we also do it in a way that's sort of robust and enterprise class, which is something that we hang our hat on. So without further ado, we'll jump into the agenda. I'm going to first sort of do a little survey about some of the services that Salesforce provides. And the trajectory for a few of us have been here a long time. When Salesforce started out, it was a pretty specific contact manager, a pretty concrete application. And over time, we were on this trajectory of transforming into more of a general purpose computing platform. And we actually encompass lots of different cloud services. So I'll just introduce a little bit about that. And then, by way of example, we'll drill into a few sort of interesting areas that illustrate some of the unique challenges and unique solutions that we have. It wouldn't be a presentation by me if I didn't talk a little bit about our custom schema and the query processing and sort of the database, which is the foundation. Pardon me, my voice is a little weak tonight. Which is sort of the foundation of everything we do. But then on top of that, business intelligence is kind of an interesting illustration of taking that core schema and doing interesting things for the end user. It's an area of a lot of focus for us. There's things like versioning and our application distribution model and ISVs and Force.com, which we'll talk about. There's a little bit of an example there. And Chatter is a new application that we rolled out, which really illustrates how Salesforce, by having tons of building blocks, can sort of synthesize that into some really interesting end user and really interesting new applications. And kind of the theme of it all is it's all one code base, it's all one product with lots of different manifestations, but by doing sort of some interesting work to put it all together, we have really interesting emerging properties in the applications. So just by way of example, Salesforce runs mission-critical business software for lots of companies now. I think it's probably over 75,000 different businesses. And there are a huge range of industries, huge range of sizes, everything from our bread and butter Salesforce Contact Manager SFA to, well, with Force.com and the flexibility that provides, really a huge variety of different business applications. And Force.com is kind of the name that we give to the plumbing that lets people reprogram our service to do the things that they want. And this number is probably also out of date, but you can use those services to build a stamp collecting app or any number of recruiting app. And this is hundreds of thousands of unique applications that are fairly small operations and hardware stack is servicing for all of these different customers. Another example, a relatively new feature is the ability to run public websites on Salesforce.com. We have probably 20,000 or so of those. That's a relatively new feature. There's lots of other dimensions, but we run a lot of enterprise software for people. And on the right, there's some interesting things that we've announced recently. I mentioned Chatter is our sort of the blending of social features with enterprise software, which is something we're really excited about, and we think we're in a unique position to do a good job on. VM Force is a new initiative we announced recently, a partnership with VMware, where we're going to sort of bring some of the more traditional infrastructure-focused parts of cloud computing about sort of access to CPUs and access to disks, sort of raw disk, and blend it with our more managed cloud services around databases and security and sharing models. But we continue to push the envelope on what it means to be Force.com. Here's a little more detail, or a lot more detail. I think this slide is called the chiclet slide for all the little boxes. And at the top, we have kind of the things that you may hear us market about, the so-called clouds. That's our recent marketing about our sort of flagship application. We have the Sales Cloud as our traditional bread and butter, Salesforce automation. Customer service is more and more important to us over time. Chatter is a new, visible end user feature. But the layers underneath that is really the building blocks that make it all possible, things that we're real proud of that are frankly very hard to do. starting with the lowest level, the core infrastructure, the hardcore stuff down at the iron. We run multiple data centers around the world. We have enterprise backup. We copy all the data over fiber channel to another location in the country or the world so that in the event that one of those data centers went down, the service would continue running for all of our customers. We focus on uptime. This number is probably under what we provide, but we've had a really good track record in the last quite a few years now of at least 99.9% uptime at hundreds of millions of requests, business requests per day. Huge variety of requests, everything from let me see this one record to let me run this complicated report or let me view this complicated web page. We service it all. Same code, same infrastructure, huge variety of workload. Less than 300 milliseconds. We pride ourselves a lot on both the performance and the scalability of that. Above that, we have a lot of sort of powerful building blocks, everything from mobile enablement to custom programmable logic where you can write code that will run for you on our servers, to MVC container for doing customizable user interfaces. Lots of building blocks that you would use to build an application. And then the top row is an example, where Chatter brings things together. We have kind of the usual things around profiles and feeds and groups and whatnot, but blending the social features with our traditional strengths in access to data and sharing of data within the enterprise. So there's many things that are not represented here, but all those things that are part of our service roll up and allow people to build with Force.com custom applications or to service sort of our flagship standard package applications. So Force.com, it's this other brand. We talk about Salesforce.com, and Force.com is again all these really really interesting building blocks of technology. We have content management, and we have full text search, and we have data access, and a really powerful API, and REST services, and SOAP services. Put it all together, and the service has grown to represent lots of different pieces of computer science and lots of different powerful application building services. So now, looking at it another way, so what is our topology, and just sort of what is some of our terminology, or how do we run the service? Because in addition to the software we develop, we also run these data centers that I talked about. So how does that look? Well, starting with some basic terminology for Salesforce, when we say tenant, it's also synonymous with a company in our organization, a company of ours. So we have, when we say 75,000 different businesses approximately, that's each of these tenants, and that's kind of a really important logical unit for Salesforce. We hold fast to the rule that what one tenant does sort of stays there, both their data and their customization. And that's kind of our unit of security. And when you're a user of Salesforce today, you're sort of tethered, you're tied to one of those organizations. When you log in, you're part of that world, and you see all the stuff that's part of that organization. Now, one of our interesting problems to work on over probably the next few years that we've talked about for a long time is sort of more sophisticated identity management, where you as a user may belong to multiple organizations, or you may have identities outside of Salesforce. And we perhaps are in a good position to bring together identity sort of with the internet at large. But at the moment, users are tied to tenants. But one of the more interesting things, which I'll talk about a little bit more in a later slide, is this notion that everything you see here is all running in production on one code base. We don't run a separate code base for sort of 3 customers last month. When we do an upgrade, when we do a cycle of upgrades, within a very short amount of time, all of our servers and all of our customers get the benefit of those new features. This is an amazingly powerful thing, both for you as a consumer of our services, everyone's on the latest stuff, as well as for us as an organization. We're not having to fix bugs or fix or repair software that's a year old. By the time it's a year old, it no longer exists to us, which is pretty interesting. On the right side of this slide, we talk about a database instance or an instance of Salesforce. This is our unit of horizontal scalability. I'll talk a little bit about it more on the next slide, but we do get a lot of our customers onto one of these. And basically a pod or an instance is everything you need to run a Salesforce, and that means the database, and the application servers, and the search servers, and the content servers. Take all those things together, and you can run approximately 10,000 of our businesses. So we get a lot of reuse. With an amazingly small support staff. This number may be out of date, but we run, getting close to 100,000 different businesses with a tiny number of operations people because of the way we've architected the service, because of the way we've architected the software. So it's incredible economies of scale. Digging a little more into what one of these pods means, and here's representative. We have NA, which stands for North America. This sort of this is the 16 across the top. And maybe if you come back a year from now, we'll have 25 or 30, but we don't grow this very large over time. We don't grow that number very much. We really like to compress lots of compute power and lots of customers into a fairly small stack. I recently went and toured one of our data centers. There's actually, computers being what they are now, just like a couple racks of computers can run all these businesses. It's really amazing. Just like a few racks and a bunch of power, and we are basically replacing tens of thousands of machines that in the old model would have had to exist. But again, inside of one of these pods, we have, for the most part, a lot of our software is written by us. We do use, jars and other open source projects, but the real major piece of commercial software that we stand on top of is Oracle. Probably not a huge surprise to most of you. We use Oracle RAC. We have 8 machines that are connected, clustered together. That forms the core of our service. We have application servers, which run our Java code, which surround that database. We have lots of other servers, again, for search. We do integrated full text search. That's running some of the scene code. We have content servers. We have we have load balancers. Put all those things together. It's not that much hardware, and that's kind of one of these pods. And so we're pretty good at rolling them out and pushing the code out to them. But on the right, you see we kind of use standard stuff. We use Dell and Linux is where we used to use Solaris and more proprietary things, but we've gone commodity hardware. And we've managed to get really enterprise class scalability from the building blocks that we use.
Quick question.
Yeah, sure.
Is this presentation available? The slides?
I think we can make it available. Yeah, this is sort of a bunch of slides that have been presented and made public in the past, and it's a little bit of a new presentation, but we'll put it online somewhere for you. I'm sure if you talk to Ron afterwards, we'll figure that out. So you might be asking yourself, why go to all this trouble of trying to squeeze so many of your businesses onto one stack and share everything? And gosh, that must be hard. And it is, but it's kind of what we bet the company on for a long, long time. And sort of the proof is in the pudding. It's worked out pretty well for us. And many times we've been asked something like this, and we think other competitors or other multi-tenant vendors have not taken this to heart quite as much as us. But a new customer comes along a few years ago, a big company, and says, we like what you're doing, but we really want to run it in our data center. We want something special about it. Can't you just clone your service and give it to us and we'll run it? Like, we have an IT department. We could have done that. We really resisted it, and it's just a philosophy, which is as soon as you start doing that, it's kind of a slippery slope. We did that a bunch of times. Pretty soon we have our software running out there in the world. It's really hard. They don't want to upgrade it at the same schedule as us, and we lose a lot of the benefits. So we have really held to our guns, and it's worked out pretty well for us, but it's not easy. And a lot of the magic and the secret stuff that we have managed to do is sort of directly tied to this philosophy. So just to sort of further hammer home this point of the magic of what we do, 15, 20 pods, databases, whatever you want to call them, each one running probably less than 100 servers. Everything we have, we double, because the live system will be running in California, and the backup for it will be running in Virginia, say, or on the East Coast. Pretty soon we'll have more data centers, by the way, and all of them will be running some active and some passive. Even if you add all that up, it's just not that many servers. It's thousands, and we're running tens of thousands of businesses. So that's pretty cool. And this metadata-driven architecture, I haven't used that word yet, but that's another sort of core tenet of the service, which is each one of our tenants uses our UI or a metadata API to turn a bunch of knobs, which we record in our database, and then at runtime, everything that you as a business have said you want Salesforce to do, we're able to manifest. And we're able to do that in parallel for all these businesses on this relatively small hardware stack. We have a ton of metadata caching. We're really good at it. We're constantly swapping in and out. When your request finishes, that thread on that app server is immediately going to be used by some other person with maybe in a different company, and it will look just like it's supposed to look for that person, not like it did for you. So we're really good at this. This is the central tenet of how we do things. Hundreds of thousands of unique applications come out of this fairly small hardware stack with one single code base, which is pretty neat. So that's the trick, is that our code base has these kernels, as I think is coming on a later slide, and the metadata that you as a customer provide, combined with those kernels, renders your application. That's kind of the model to think about how our application works. And again, we've taken this to heart. We've taken it probably further than it's ever been taken, at a scale that's never been taken, and it has led directly to our success. So before I get back to that, persistence is kind of the name of the game for us. we hang our hat on being a database. We're a real database. We're an ACID database. We have all the nice properties of a relational database because we're backed by one. Now, as an aside, we're actually looking at also bringing into our world some non-relational things, some non-relational properties, and I'll talk a little bit about that, especially in the analytics section. Because for some very large operations, we actually can loosen some of our very tight rules about consistency and whatnot, but I'll talk about that in a second. But we have spent a lot of time on storage. There's lots of different places where data resides, obviously, in our service. And I mentioned caching, and this is just a little flavor of the different tiers. And you know, if you were a Salesforce developer, you'd be intimately familiar with, oh, is that data stored in distributed cache, or is it stored, in transactional cache? So, just to give you, a sense of the way that we think about things, we have layers and building blocks. We have spent a lot of time on a memcached-based architecture for, really fast access to things in memory, etc. However, if you think about it, if you're an admin of one of our customers and you make a change to the metadata, all of our application servers need to see that metadata consistently right away. If you change a layout, you don't want some of the servers to see that 5 seconds from now and some of them to see it a minute from now. So on top of the basic caching layer, we had to build a transactional layer that guaranteed that everyone would see the same thing, even though we have stateless app servers. So that's what we call sort of our metadata, our transaction-aware cache. And that was building blocks that we had used for many years as part of our standard application. Yes, Dave.
So when you say metadata, you mean the company's individual configuration of the
configuration, all the knobs. And it means things like basic stuff like what are your objects and your schema? What tables have you defined? Because that's one of our bread and butter things is we let each of our customers not only add fields to existing objects, but add brand new objects. But then it's what's your layout? What does your screens look like? What are your workflows like? What are your triggers like? Et cetera, et cetera. So all that stuff we consider metadata. It all goes into this cache. As a philosophy, our application caches metadata and Oracle caches data. So we have billions and billions of rows in Oracle. We don't want to slurp that into Java. That's what Oracle's SGA is really good at. So that's kind of one way that we think about cache. Now a few years ago we said, okay, we have all this metadata that we use in our application. We define the term layout and workflow. That's the Salesforce concept. But as a platform, and this is where Force.com comes in, we said, hey, if you want to build something on Force.com, if you want to build something on Salesforce, you might want to define your own metadata that applies to your users. And you might want to have really fast access to it. So that's when we introduced this feature called custom settings, which is built on top of the transaction-aware cache, which is built on top of the distributed memcached implementation. And this is a really cool feature that lets our customers define their own properties of a user or an org or profile. And for instance, they can access those things almost for free in their Apex code. They don't have to do queries to get it. It's just immediately available to them. So that's kind of the evolution of us from sort of low-level services all the way up to a Force.com service, which is taking these cool building blocks and presenting it to the outside world so that they can use it to build their own applications. Yes?
These memcache servers, is this some custom hardware you have? Or so?
The memcache processes actually run on the same servers that our application code is running. And it's a distributed memcache service where we could run it on different servers, but we decided that we didn't need dedicated hardware to run memcache. It's just, we got plenty of memory in those boxes. A certain amount of memory is assigned to our Java heap for our application, and a certain other amount of memory is assigned to the memcache servers. Yeah. That happens to be the topology we've chosen at the moment. As it turns out, a certain other bit of each of those app servers is where our chart server runs. So like the pretty pictures that our reporting engine creates are generated on app servers, and it's a separate process. But that's just sort of that's just a fact. It's a quirk. So more on line of persistence. Now we're talking about kind of real data, customer data, not metadata. Things like what are your accounts or what are your documents? Well, so we have our classic Oracle data, and it's built on top of a classic, very expensive SAN, kind of the most expensive you can buy, enterprise class, super fast, super reliable. It replicates data across the country, using very low-level technology. It's really cool. But guess what? It is expensive. And so for your relational data that you're reporting on, you need that speed. For your documents and your blobs, it was kind of a waste for us to stick those big binaries into the SAN. It's expensive. So relatively, in the last few years, we sort of built our own file store, a content server, if you will, to store these big objects that are read. They're written occasionally and they're read occasionally, but they don't have to be super high performance. We did that for us so that we could, frankly, store more of them, and it would cost us less, so that we could allow our customers to store more data, and we have to charge them less. So this is another example where sort of storage excellence is something that we've been working on. Other examples of interesting storage, we have the need for kind of persistent storage, but not so bad if you lost it storage, sort of semi-persistent. We use this as an example. For those of you who have used our API and have done a big query, we built a few years ago a really powerful cursoring mechanism where you can do a query against 1 million rows. And what happens is we run the query on the server, we store the 1 million IDs, and then we give you them back in 2,000 at a time. But where are those IDs stored? They're stored in this temporary place, and they're live for about an hour. And as long as your client reads the data within an hour, you'll get it, and if not, it'll go away. So that was the original purpose of this temporary storage. We found a bunch of other reasons to use it for chart data, et cetera, for example. But that was just another tool as another arrow in our quiver. And more recently, I'll talk a slide about this. This is actually new stuff and forward-looking stuff, where we're looking at storing data outside of Oracle for persistent relational data that doesn't change very often. So if you have 1 billion historical records that you want to give us, that's a little much for our Oracle storage, but we would like to be able to take that 1 billion records and do reports on it, as long as you're not changing it every second of the day. And that's something that I'm working on and a number of other people are working on. So the evolution of our storage continues. And it's really a core expertise of ours. Yes?
You said as long as you're not changing it every second of the day. Where's the cutoff where it makes sense?
Basically, for
Are you
high...
updating or?
You will be able to update the data, and you'll see the changes reflected, but that store won't be optimal if you were going to be doing reading and writing rows, every second of every day. It wouldn't be as optimal as if you. That store is going to be optimized for kind of bulk inserts and occasional updates, which is satisfied by a lot of the large data sets. And there happens to be a lot of data sets in the world that are write once, that are log data or transactional data that never gets updated. So it'll be another important arrow in our quiver.
Thank you.
Sure. So here's another building block picture of kind of the way of our system. And this will lead a little bit into the schema design and the query design, which is, on the left, this persistence that I've been talking about. It's particularly the Oracle persistence. Inside of Oracle, we have data tables. That's your data. That's your accounts and your custom objects and your business data. And then there's your metadata. And we have actually a lot of tables. The metadata is more complicated. It's less rows, but it's complicated. We have lots of tables. And then there are these things called pivot tables. Pivot tables are the redundant data structures we build to make things run fast because we're very flexible. We have lots of patents, actually, some issued, some in the pipeline, around this cool custom schema where we give everyone the illusion that they can have their own database. But in fact, they don't have their own database. We don't create tables for people. You can't create hundreds of thousands of tables in Oracle. It would fall over. But we're really good at building some data structures, which I'm going to describe now, that allow you to store kind of arbitrary data. But typically those structures don't work really fast, so we built some other structures to make them work fast, which I will describe a little bit now. And then you have all this code on the right, these kernels. You have the metadata kernel, and you have the optimizer kernel, and the thing that generates the UI kernel. And that basically those pieces of code are fed your metadata and your data, and out pops your user interface, or out pops the response to your report. And that is the function of our system. In this case, your application comes out. A little bit more background. Security. Salesforce would not exist if we were not very, very focused on security. So before I digress into the table structure, I'll say again that every table in the system has a very important column called org ID, organization ID, tenant ID, if you will. And that basically, if you're customer X, all of your rows have the same value, and customer Y has a different value, and pretty much every query that we issue filters on that, as you might imagine. And we have lots of, and so that's at the data level. And then when we're processing your request in Java, if we're working on rendering UI, you're assigned a thread. We use lots of thread locals so that for the life cycle of your request, we know who you are, we know who your org is, and you're only going to see stuff relevant to you. And when those objects are put back into pools, when we put the thread back in the pool, and we put the database connection back in the pool, we clean up all the data structures, we clean up all the thread locals, so that that thread and that database connection excuse me, is available for work for the next person to come along. So that's kind of our basic flow. We have lots of static checking in our code. We have analysis of our SQL to make sure that we always filter, and that's kind of the way we do things.
Do you use like VPD or something there?
We don't, no, it's all hand done. We are just issuing SQL. We're not using in many layers on top of it. We're not using virtual private. The question was VPD, Oracle Virtual Private Database, which is a way of injecting filters based on who you are. We do that all ourselves. We do all that ourselves. We also, our object relational mapping layer, which is typically used like something like Hibernate or JPA to get data from object representation in Java into the database. We wrote that ourselves. We wrote it in bulk. It's aware of our funny data structures. It's a core competency of ours. And so we wrote it ourselves. I guess before I get into the data structure a little more, there's some other really important things that we do. We've got security. We also have protect the site. Because we're a shared, we're sort of a timeshare, we're a fancy new timeshare, we need to make sure that no one accidentally or maliciously hogs too many resources. And boy, in the number of years I've been here, the creative ways that the system can accidentally be hogged are amazing. So we have to be pretty diligent and paranoid about this. So we built a lot of, this is where we built a lot of core services. We have a clustered service that keeps track of how much of something every tenant is consuming. How many requests are you doing right now? How many requests have you done today? Have you gone over your limit? Are you getting close to your limit? We warn you. So we're watching. We're like Big Brother, but we're kind of a benevolent Big Brother, we hope. Apex, which is our procedural language, you can think of it as a place to write triggers and store procedures, if you think of it as a database language. Because it's a shared service, because we don't want you to accidentally get into an infinite loop and update the same row a gazillion times, Apex is a governed language, meaning we watch how many database queries you run, and we watch how many updates you do, and if you go over a certain limit, we hit you on the head. This is, not everyone loves this, but everyone gets along. And in fact, we encourage people to write more efficient code by some of the rules that we have. It's, it's a give and take, but it's led, Apex has had very high usage. I mean, I forget the numbers, but it's like hundreds of millions of lines of Apex code that we're running every day for customers. So we've gotten along pretty well here. And even the things that we've decided to opt into the platform or into the language of Apex, we've been very careful. People would say, well, why did you kind of invent your own language? It's Java-like. Why isn't it just Java? Boy, it would be really hard to control all the things that someone could accidentally consume in Java. I'll just give you an example. We added regexes, regular expressions, to Apex, and we just made it pass through to the Java implementation of regex. Well, it's possible to write regexes that use lots of CPU, and people did by accident. And guess what? The service would go down, or we came close to that. So we had to implement kind of a creative use of a car sequence where if you tried to do backtracking too much, it would count the number of times you backtracked, and if you went over a certain number, it would stop the regex. So that was an example. Another one was we added math arithmetic, big decimal arithmetic to Apex, and if you say, big number to the power of another big number, it uses a lot of CPU, so we had to limit that. So even these little things that you think would be kind of basic, those are sort of abusable. And we've been very careful about what we've added to the platform to make sure that, that it is a friendly place, that people can get work done, but not hog too many resources. Okay, so now we'll talk a little bit more about data structures and query processing, which is a really good example of our, how we've done things. So again, sharing, that's what we do. Share data structures. We share your metadata. Sharing means it's all stored in the same tables. We have a table that stores all the layouts for all of our customers in that pod, and it's one table. Then we have another table that has all of the accounts, literally the billions and billions of accounts, or the billions and billions of custom objects. That's all in one table, and I'll talk about that in a little more detail in the next few slides. And then we have these creative pivot tables or index tables or sort of denormalizations of the data so that if you issue a selective query, we know how to get that selected answer quickly. Starting with that table in the middle, just the big pile of data, we use flex column, which is a technique that people have used for years. So one of these flex tables will typically have a unique ID, that's the primary key of the row, and then there'll be a column that is actually an ID, but for the sake of argument here, it's just what customer. So as you see from the tenant ID, some subset of the rows belong to one tenant, some subset of the rows belong to another tenant. Within this object, though, and this is the custom object table, even within HERAs, you can have some of the rows that belong to one object, like let's say hotel rooms, where data 2 is storing a hotel price rate per night. And then some other rows are in the same table, but are actually storing a different object, which is casino games, for example. So what you'll notice is the same physical column, and that column is a text column, so we really do store all this flex data in text, and we convert it to the appropriate data type when we need to. It's all just stacked on top of each other. Boy, that's awfully confusing to Oracle. Is this mic okay? I thought I was getting a little feedback. So this structure alone would be not so good. You got numbers and dates and text, and where it would be not so good would be if you said you had millions of hotel rooms and you wanted to find all the hotel rooms that were above a certain dollar amount. Well, you really need to store the data as a number and use an index on the number column to find that. So this isn't going to work. You can't put a number index on a column that has a bunch of different data types in it, not even a function-based index. So what do? Instead, we clone the data into both data structures. We have the heap data structure on the left, that's what we call it. If you did a report and just wanted to look at all the data, we'd use that. But if you wanted to come at it the other way and find data with a particular characteristic, we would use this other table, what we call a multi-tenant index table, which is a very, very, very tall table that has all the cells of all of the index fields of a given type. As a matter of fact, this table has 2 columns. It could be 2 different tables, but it has 1 column for all the text values and another column for the number columns, and it has a 3rd column for the date columns. And those columns are really are dates, numbers, and text, and can be indexed as such. So our optimizer, which I'll be talking about in a second, has to know that if the user wants to filter on hotel rooms that are equal to $270, it has to first look in the index table and do the appropriate filters for this tenant, that column, find the row IDs that are matching the criteria, and then join back to the big table to get the other columns that the user wants to see. This is kind of analogous to what Oracle does when it transparently uses indexes, but unlike there, where it's just an index on a table, here we have to actually add another table to the query. So this is where you get the notion of a multi-tenant optimizer.
So there you have index on every column, multi-tenant index.
No, so on the left we have a very wide table. It has 500 columns. It has no indexes. On the right we have a very tall table that only has 1 column for each data type, text, number, and so there are 3 indexes only. 1 text, 1 number, 1 date. And
all data of that particular type goes into column.
Exactly. But only, so the administrator has to, we don't do that for every cell of the grid. It would be, trillions of rows. Instead, sorry, the administrator has to say, this is a column that the user wants to filter on, and they're limited in how many they can say that on. But if it's a column that is indexed, then when we write to the big table on the left, we'll also write to the big table on the right.
And then you join them by the primary key, the ID.
Exactly. Yeah. But that query would have to start on the right, find the rows, and then nested loop over to the left. So that's an example of a sort of selective optimization table. This is a more recent one, a little bit. So what we're illustrating here is that this redundant data structure on the right, what we call a skinny table or a reporting index, is more like a covering index. So on the left, you have a very wide row. Maybe your business stores hundreds of custom fields, and there's lots of text, and it's a big sloppy table. But your users only want to run a report on 5 really important fields. So we will actually build for you a skinny table that only has the columns that are going to satisfy a particular. So this is a technique that people have used. It's a materialized view, or it's a covering index. But we will do this transparently in the background. The administrator just says, hey, here's a typical set of columns that my users want to filter on, and we'll go ahead and maintain that data structure transparently. You'll go ahead and do your API calls and read and write the data, and we'll just maintain this, and we'll use it whenever. So it's just another example of an optimized structure that we build to make queries run fast. So here's a kind of example real user scenario that I'm going to illustrate some of the choices that our optimizer has to make. Because A good optimizer is able to decide among various strategies how best to answer that. Now, I mentioned one strategy, which is you have a selective filter. Well, there's actually another really important filter in our system, which is what rows can this user see? Let's see. Right, visibility. So, for those of you who've used Salesforce, one of our really powerful features is a really detailed sharing model. You can say, here I have 1 million hotel rooms, and these users can see hotel rooms over here, and these other users can see hotel rooms over there, and they're never supposed to see rows that they're not allowed to by the sharing model. We store that information in a pretty detailed set of tables, and whenever a given user runs a query, they're only supposed to see the rows they're supposed to see. Now, as an example of different ways of evaluating that, if you're the CEO of the company and you have access to lots of rows, then there's a certain query plan that makes sense for you. If you're a low-level sales rep and you see a very small number of the rows, there's a different query plan that leads with your sharing because it's such a small set that it makes sense for you. So if you think about it, sharing is like another filter, and it's another filter to be evaluated against these other filters. The sharing is stored in this multi-tenant table that has the sharing information for every user of the system. And we need to decide, is that the right place to start a query, or is some other filter the right place to start a query? So that's what our optimizer does. Like a good optimizer, a cost-based optimizer, it keeps statistics. Now the low-level database, Oracle, it doesn't know about all this gobbledygook we're doing multi-tenant. We just got these big giant tables and it's confused. But us, our code, we know what rows belong to what tenants, and we can, every day, calculate statistics, like how big is this object, how many rows can that user see, how many values are in this pick list field, and we do. So we collect multi-tenant statistics, we store it in our own metadata, and we use that information in our optimizer to tell Oracle the right way to answer a query. It's pretty powerful stuff. So as an example, that query, Michael Dell wants to know what's selling well in the Western region. There are 3 different filters implicit in that statement. The Western region, Michael Dell and what rows he can see, and the product line, servers. The reason Michael Dell is not the right place to lead that query is that he's the CEO, he sees all the data, it's not a very selective filter. Our optimizer would decide this dark line, black line, the Western region, it happens to know is the smallest subset of rows, and it's going to lead the query from that. And we would navigate our funny data structures and answer this query quickly, and we do. And so we store data in text, we store it in this big grid, we keep these other data structures for sharing information and for indexes, and our optimizer outputs SQL that joins the appropriate tables together, and voila, you get multi-tenant query optimization.
Is there org ID filtering on the index table, so there is no org ID there?
There is org ID in every table. And it's always the first column of every index on that table. So you always filter on the org. That's actually good. That leads into this the physical notion. We use Oracle partitioning. So every one of our tables is actually 32 tables. 32 is just kind of a number we picked out of a hat a while ago. And by doing that, once you filter on an exact org ID, it throws out 31 out of the 32 partitions because Oracle knows which one of those partitions applies to your org. So that's an immediate way to scope the rows right away. But then it hits the rest of the index and goes from there. So that's a good, I'm pretty fond of this whole example, but it's a good, at the bottommost level of the database and queries, which is a lot of what we do really well. Because frankly, it'd be relatively not so hard to build a lot of the services that we have, but to build the services we have at scale we have is really not easy. So, analytics, business intelligence, nice segue from where we just worked. Neat thing about Salesforce, again, lots of different things thrown at this code base. Lots of different apps, lots of different services. Our bread and butter, we started out life as a transactional system. You give us your business data, we give it back to you. You transact an order or an opportunity, we show it to you. But, another big purpose of databases, once you have a lot of data, is to do big, broad, executive analyses. And our approach has always been this, which is we don't build a separate data warehouse. There is no separate data warehouse within Salesforce of all the data copied every night and turned into a star schema, etc. We have gotten quite far with running analytics-style queries because of some of those optimizations that I just mentioned on the same data structures, which are up to the second when you do your reports as your transactional system. Now the benefit of this is, well, it's not out of date, which is a big problem with a lot of data warehousing strategies. It's a big pain. You got to extract the data. It's out of date. People are confused. We've also sort of tried to democratize analytics. We've tried to democratize a lot of the services that I'm describing, which is to say, you don't need to be an IT person to set this stuff up. A business user can define a report. The report is guaranteed not to go on and run forever because we don't let you run things that run forever because our optimizer won't run it if it won't finish quickly. While at the same time, and this is the balancing act for us, is we want to be flexible and powerful and let business users do what they want to do without bringing down the service or without doing something foolish. And that is the art for us, is to give powerful building blocks and in some cases take away the most powerful things, but to do it in a controlled way that everyone's happy. Sharing model, consistently built in, that's part of our philosophy. So this has always been important, analytics. But I'd say in the last couple of years, we're really taking it to higher levels, and we have even more exciting things coming out. It's coming Dreamforce and over the next year. But boy, just in the last year, we have some really impressive numbers that a lot of the reasons people have to build things in another system is just that their core system wouldn't produce numbers like, we handle 200 million SOAP calls a day, let's say, 200 million plus API calls per day. I don't know if that number, give or take, is about right. You can use our bulk API, which we've optimized. If you send us lots of records at a time, we pretty blazingly fast. In parallel, can process lots of different orgs, 10 million rows an hour. You can build up a lot of rows that way. And we have some customers that have very substantial size records in there. Again, lots of business-driven functionality, really easy to use our analytics. And so we've already, we're very proud of where we are. This real-time nature, kind of the nature of the cloud is, gosh, you don't want to, people are a little OCD, they don't want to wait a day to see their reports, and that's sort of driven a lot of our design decisions. And just as a teaser for something that we're working on actively now, an area of research, an area that a lot of people in the world are doing, which is, okay, relational databases are great, we certainly love them. They do kind of top out. There is an expense to the ACID properties in the log. It's all one log. Every update you make to Oracle has to go into the redo log. There is a pretty big expense to that. So for this class of data, which I mentioned before, which is give us all your high volume data, all of your transactional historical data, let's call it, and you want to run reports on it. We want to service that business. We are a data focused company. We want to take billions of records of our customers, so we are blending some of the techniques that are going on in the world about non-relational stores. Parallel processing, commodity hardware, Hadoop, NoSQL, and so we are working on that. Stay tuned for further announcements, but we're going to blend the two together, the same API. The cool thing about what we're doing is we're blending the same APIs. You'll just sort of transparently write to one store or the other. A little bit of functionality you'll give up in exchange for massively more scalability. And we intend to make this transparent and just another powerful cloud service that we provide. So that sort of covers a lot of our core data functionality, and I want to talk kind of an interesting example of something more in the sort of configuration and programmable part of the world, which talks to how we do upgrades. And this is another real thing that we hang our hat on. One of the great things Salesforce has done over the years is smoothly update everyone, release after release, give them new functionality, and preserve all their customizations, preserve all their API traffic, all their clients continue to work. So we've been doing that for our customers for years. But we want to give that same power to people who build. So if you build an app and you put it on the App Exchange, our App Exchange is our market where you can sell your work into other Salesforce customers. How do you upgrade your app in such a way that it continues to work in their org no matter what customizations they've done to it? It's a really hard problem. Anyone who's ever worked on sort of versioning and upgrade scenarios will know this. What are sort of some of the challenges? Well, Salesforce does major upgrades 3 times a year. We have for a long time. We used to do them a little more frequently. We used to do them all one night, Friday night, 8 a.m. A bunch of people in this room would be up all night. And we'd cross our fingers that it would work on Monday. We're a lot better. We're a lot more methodical about it now. And we actually stagger it a little bit over a few weekends, but you don't have a choice. If you're a customer of Salesforce, this is a great thing most of the time, but you don't have a choice. What it means is we can't accidentally break anything that you were working with before. So we have this notion of a contract. If you are talking to our API, we have very well-defined rules about what that means. And I'll describe that in some later slides here. But you bind to our API with a certain version number, and we will preserve all the behavior of that version. Even when we rev our server, we will continue to support the client version of whatever we support in the past. Now, secondarily, we want to give that same power to our ISVs to develop stuff and upgrade it, and I'll talk about that in a second. But here's this whole thing we've really taken to heart. You know, there are a lot of clouds, there are a lot of web services, and people sometimes deprecate them after a few months, and if you're using it, too bad. Well, we don't do that. We actually have kept most of our APIs for years, probably more than we should. Things we don't change is if we had an object out there, if there was an account object, it's not going away. If there was a verb, like describe, which is one of our API verbs, and you were using it, it's not going to go away. We may rev the server, we will preserve that. And even the behavior of what that verb does, subtle things like bugs, we will preserve them. So we have this really firm handshake that we're very proud of. There's a particular engineer at Salesforce who's been sort of the czar of this, talking about Simon Fell, and good thing because it's been really powerful for our customers. So the neat thing is we don't actually run the old version of the server. We're not running last year's code so that your crappy code that you wrote last year continue to work the way it is. We don't do that. We remember one code base, always the latest code base. So what it means is that when we rev our server like we did in this, for 2010, it has to be able to emulate all these old client versions. And you might think that we have all these if statements and giant gobs of old code, but we don't. We've designed our API in such a way that it doesn't change that much over time. We do have some sprinkles here and there. If the client thinks it's version 13, do this, otherwise do that. But it's not as much as you might think, because I think we designed our API pretty well. Another way to look at that is that every time we rev the server, we add a new latest version, and all the old ones are emulations. So when we come out with version 19, it's literally like yesterday version 18 was the latest version, and tomorrow version 19 is the latest version, and that code needs to be able to emulate version 18. And it's a marching forward. I hope someday we'll actually deprecate like version 6, but we haven't. So, we've deprecated like 2 things ever. It's embarrassing. So what if we really do want to deprecate something? So we don't just take it away, we sort of smoothly take it away. This is kind of an obnoxious example, and again, if you've ever used Salesforce and wondered why we have an object called product2, well, we had a product, and it died. These numbers, by the way, 134 and 142 are internal numbers. They probably correspond to like version 6 and 8 of the API. And what this basically says is, for a little while, between 134 and 142, they both existed. But once you got past, if your API version is greater than 142, product doesn't exist to you anymore. And if you're less than 134, then product 2 didn't exist to you. But we kind of encourage everyone to build new stuff on the latest version, so gracefully old things fall away. But if you really want to, you can still get the product functionality and bind to an old API version. So that's the shape, because this is an object. This is like an S object, which is our data row, and it will exist. Similarly, for verbs, like describe, we have something called describe S object, and 5 years ago, we didn't have the notion of a trigger, and if you did a describe, you wouldn't get told anything about triggers. But at a certain point in time, we added a property about whether this object is triggerable, and our code will literally say, like in an annotation, there is this new property that shows up as of version 150, which again corresponds to some public number. And if you're greater than that, you'll see it, and if you're less than that, you won't. And that's what we do. Now, by the way, we have extensive functional testing that asserts that all this stuff behaves the same across versions, otherwise we break stuff all the time. I'm very proud of that. We run many, many tens of thousands of tests every time we check in code. A more subtle one is, okay, the object is there and the verb is there, but does it do the same thing? And this is an example where we would sprinkle something into the code. This is probably the wrong API now, Steve, sorry about that. It's close enough. But somewhere in our Java code, if you really wanted to change behavior depending on what the client thought it was, you would write something like saying, if the current version is at least 142, then do this, otherwise do this other thing. And this is just a silly example, but you will see this sprinkled throughout our code, and it is what affects the behavior changes. So we've been doing this for years, very important stuff. I don't think anyone's ever done it, frankly, before. I mean, it's kind of a crazy thing. We have one code base that we march forward that emulates everything we've ever done. Now you're an ISV, and an ISV takes a bunch of metadata and packages it up and sticks it on AppExchange, including code, because they can include Apex code, that's real code. And they hang their shingle out and say, please install this and pay us money. That's version 1. Now version 3 comes around and they regret something they did in version 1. How do they change it? Well, we thought they should do it the same way that we do it. So we've exposed in Force.com a lot of this stuff. First thing we had to do is when you upload a version of your app, you have to give it a formal number. That number is ever increasing. And the first 2 digits are the major number, and then the third digit is the patch number, and I won't get into the detail of that. But we call this a structured version. And it roughly corresponds to the API version numbering scheme that we've always had for our SFTC API. Similarly, you know, many of you probably never seen, like when you define an object, you can actually make it go away. You can say, everyone who was already using this object, they can keep using it, but anyone who newly installs my app, pretend I didn't do it, it was a mistake. Yes?
One thing I don't understand is, let's say I'm writing Apex code, and I use a verb or an object. When that API call gets sent to the server, how is the correct version number included?
Because every piece of metadata, including every API client and definitely every piece of Apex code, records the version that it was using at the time. So when you write Apex code, we immediately latch the version of the client that you wrote it with, and that guarantees when we compile it 2 years later, we'll know exactly what it's supposed to look like.
Oh, okay, so I don't have to worry about putting the version number in there.
You don't. Well, basically, if you just say new Apex file and save, it'll save you as the latest one, but it'll remember that number. So if you come back and you can actually change it in a drop-down, but if you don't change it, it'll just stay. And just like we did that for our API version, if you're writing Apex code and you're relying on someone else's Apex code, you'll remember the version of their app as well, so that if they rev their code, it'll all be the same. So we basically latch the version. So you can take away your objects by clicking this button, which will, through a series of events, cause that object to disappear in the next version of your app. And here's a bit of Apex code. And notice the is greater than. So in your Apex code, you can basically say, if the person calling me thinks that his version is greater than this version 1.1, then do this. Otherwise, do this old thing. You can ignore the syntax, but basically you've exposed in Apex the same thing that we have in Java. And this number has to correspond to an actual number that was released by the customer. So this is it. You know, again, in the language itself, we have this concept of versioning, and it talks to the life cycle of application development, the same way that we've been using it. By the way, at the top there where you see that tab that says version settings, David, that's where it would say what things you were bound to. So here's just some more facts about this neat thing. When you write code as a partner and you want to rev your code, you don't, again, ever have to edit the old version and keep it around. You only write the latest code, and you are responsible for emulating bugs or whatever of your previous versions. You are not allowed to add new methods or take away methods arbitrarily. If you released a method with a certain signature, you can't ever take it away. You can deprecate it, but you can't just delete it. And then this whole binding mechanism kicks in, and that's what we do. And pretty cool stuff. So that's just, you know, one little interesting corner of Force.com that we learned through experience how to do it, and that's kind of the history of Force.com is we got good at something, we said this is cool, let's let everybody else do it. Now, Force.com is an interesting one. A lot of us who are, you know, this is in some sense the cool things we do is this platform features. It's tantalizingly close to a complete development platform. We have lots of stuff. We have a database, and we have code, and we have UI. You can nitpick, and in fact, there's a lot more for us to do. So we are trying to do a lot of things by building a full platform. We have a lot of success, but there's a lot more for us to do. And you know, maybe eventually we get to a point where we have everything, but it's an interesting continuum for us. You know, really cool thing that we finally released recently is that sort of the drum roll of all of what I just described is If you are an ISV and you develop a managed app and you discover that there's a bug in it, as long as you don't change the surface area of that app, you can actually push a fix to all of your customers. They don't have a choice. It just installs the fix and it's just there. It's automatic. That's what we call a push upgrade, which is totally analogous to what Salesforce has always done when we do a major. Now, this only works for minor versions right now. We will do it someday soon for additions, meaning you add something new to your app and you want to push that out to your customers. But this is a big step that, to my knowledge, has never really been done in enterprise software, where you can automatically push a fix to all of your customers in our ecosystem. And that is in production now. It's a culmination of a lot of hard work. So along the lines of stuff we need to do still is, we've started on this, but if you're developing a managed app, you actually have to do it all inside of one tenant right now. You get an org called your development org, and that's where you do all your work. We really need to make it more like real team development with branches and sort of code repository. We have more work to do there. We know what to do. It's on our roadmap, but there's many things we have to do. More challenges in this world of platform.force.com, debugging. Our servers are on the other side of the world from you, and you want to put a breakpoint and pause a database transaction in the middle and see what's going on. That's pretty hard. We might let a small number of people do that, but we'd quickly run out of database connections if we did that. So we don't have a great debug. We have printf debugging. That's not so good. This concept of an omniscient debugger, where we basically, while your request is running, we record lots of information, we send it to you, and then you can kind of step through the trace of what happened. It's better, but it's still not great. We haven't figured this out yet. We might allow a small number of our developers on a separate development instance to do real debugging with breakpoints and hold the transaction open for a certain amount of time, or we might not. That's an operational challenge for us. So there's real challenges to developing in the cloud when it comes to transactions in particular. Like, transaction is not something you can easily serialize. So that's a fun one. So finally, before I turn it over to questions, another just building block, lots of interesting low-level stuff, higher-level stuff. Chatter is a really cool example of putting it all together in synthesis. If Chatter was just Facebook for the enterprise and it was just, you can have a home page and you can have some information about yourself and you can have groups and you can have a feed and talk to other people, it wouldn't be that interesting. However, and here's, this is a marketing slide that describes, where the world is going and why enterprise software needs to behave more like consumer software. And this is all good stuff. Our CEO is very hip with mobile devices, and we'll be doing a lot more with mobile devices, etc. But the real killer thing about the real killer thing about Chatter is the things that you're doing feeds on and that you're recording information and sharing with your colleagues is your business data. And that business data honors the sharing model. And so when you show up and you see your feed, it's not just so-and-so, so-and-so is in this other, so-and-so is in a sales call over here, that's nice. But it's also your data is talking to you. Your opportunity that you're working on, somebody edited, and inside your feed, if you can see that opportunity, you'll be notified that the opportunity amount changed from $50,000 to $30,000. Maybe that's something you should look at. So this is really the killer part of Chatter. Which Salesforce is in a unique position because we have the scalable database, because we have the sharing model, because we have all the metadata to bring, sorry, my voice is really going, to bring a lot of the sort of more modern collaboration features and blend it with traditional enterprise software. Oops. And just a few more little descriptions about some of the features, putting it all together. The neat thing about Chatter is if you build an app as an ISV and you had custom objects, you literally just turn it on. You just say, let's Chatter enable this sucker. And now all of a sudden, if it's a stamp collecting app, my favorite example, you can start having feeds and posts and groups about your stamps. It just works for free. So that's a pretty cool illustration of how all these interesting building blocks get put together into very rich and powerful top-level applications. So, if my voice will stay for a little while longer, I will take further questions, and I think we're doing pretty well on time. Thoughts?
Who do you think of as the biggest competitor?
Well, there's a lot of different dimensions of that. Our philosophy, so let's start with Force.com, which is sort of near and dear to my heart. Like I said, we built a lot of cool computer science, a lot of cool building blocks for particularly data-focused application development. But we are dinged, a lot of the things we present, Apex, Visualforce, that's our visual editor, they're kind of specific to Salesforce. The whole other take on that is things like Amazon, sort of more lower-level services, but maybe perhaps more open services. So we have to sort of balance between providing Salesforce-specific, powerful stuff and also giving developers tools that they're familiar with and sort of raw access to things and enough power. That's the balancing act between our high-level services and some of the low-level services. So, the Azures and the Amazon and Google App Engine is probably competitive there. And then on the app side, it's the traditional things. Chatter, probably competitive with SharePoint and a lot of other collaboration apps. In terms of just apps, Oracle, Siebel, SAP, the traditional stuff. But, frankly, we're winning that battle for many reasons. Not entirely. I mean, there's always a place there will be a place for a long time for people with their IT departments and installed apps. They're not going away. But boy, it's so much more efficient in some ways this way. So we have different competitors in different markets. Yes.
I'm interested in content and document management, and with the infrastructure you guys have in place, it looks like you could pretty easily do Documentum in the cloud, for instance. Talk with that market.
Yeah, so Chatter, is bringing uploads and sharing of documents kind of into mainstream for us. We made an acquisition a few years ago, which it's becoming sort of mainstream now in our product and our code base. And with like FileForce, the ability to upload. We basically want to take everyone's content and have it not be an issue. Just give it all to us. There are many features that we need to build, and we need better search. And we have full text search, I didn't mention that. We index all the relational data, we index the content data, we can do a better job of it. But collaboration, SharePoint competition, and documents are only, it's very much in the center of what we're spending a lot of time on. And yeah, it's all in cloud. Yes.
What kind of application servers do you use? Do you use something like Tomcat, or do you have your own?
Resin. There was a little bullet on one slide there. It's relatively lightweight, small thing we've used forever. It's like developed by, how many guys? 3? Coucha, yeah. The general thing there is we're pretty off the shelf. I mean, we like to say we're fully J2SE. We're just like basic Java, some libraries. We do use Resin. We pay a small bit of money for it. We could and would get off of it. We just have been too lazy. But we don't use it for much. Most of our UI is rendered sort of custom by us. We have a few old JSPs, but not very many of them. And there's certain, like thread management that it does that we could probably take on ourselves. But most of our other, so Oracle is a big piece of commercial technology that we use, but Red Hat, Dell, Linux, Resin, Lucene, lots of pretty standard things. Other questions? Yes?
So what's the relationship with Oracle?
It's complicated. It's
Like a marriage.
interesting. Yeah, Oracle is like 2 different businesses. Like the database group, the sort of bread and butter, we're buddies. We like them, they like us. We all speak the same language. We're a great illustration of their technology. We compete with the apps group, and I'm sure they hate us. But for whatever reason, we have a good relationship with the database group. And we have an enterprise license, and I don't know where that'll all head over time, but I think Oracle's great.
So do you expect to be acquired by them?
You don't really think I'm going to answer that.
Just
Yeah, no comment.
Have to get acquired,
Any other questions? Not okay.
So on the tables you
Illegal
have
venture.
org ID as the first column. For your file force,
That's not it, yeah, so FileForce is 1 file per document, but we actually do one clever thing we do with FileForce is if you have a lot of little files, we bundle it up into a bigger file. And we do
is it
that.
going to like Unix file system or something?
Yeah, it's basically our own file. It's literally the file system of Linux or Solaris. I forget what those machines are running, but we manage the files. We try to get big files. it's sort of like a little mini version of GFS or something like that. We copy everything in triplicate. We clone it ourselves to the other side of the world so that if anything goes wrong, it's always there. But it is sort of primary storage for us that we manage, that we've written.
But the same file system is connected to all your app server nodes.
For a given instance, yeah. At the moment, there's not a single giant file store that's used by all the different instances. We try to make it so that there's shared nothing between pods. That's not entirely true. One thing I didn't mention is this notion of a sandbox, which is if you're a production customer of ours, you can clone, if you want to do some development, we'll take your entire org and clone it over here to another pod where you can play with it. So there's a little bit of crosstalk between those pods, but generally speaking, yes, it's a shared file system that all the app servers in that pod can see, but it doesn't cross boundaries across the pod.
So for one, or all the files are in one directory, or you have like some kind of, with a D.
Yeah, there's like a hashing structure, and it's like an interesting tree, and it's a balanced tree, and there's details there, but yeah. One more question. Running on. Yeah.
My question, you mentioned load balancing. So between the application servers, are they stateless, and how do you manage that?
Yeah, one of our basic tenants from day one has been stateless app servers. We briefly, for a while there, we had a time where, from the point of the load balancer, they can send any request anywhere, and you can bring the app servers up and down, it's fine. So yeah, there's a cookie on the, when you log in, you get cookie with a random string, which maps to the session ID in the database, which we check on every request to make sure it's still live, that sort of thing. We used to play some games where the load balancer would send you to any, and by the way, like for a pod, we probably have about 30 app servers in general, give or take. We send you to any one of them and anyone can answer it. We used to try to sort of send all requests for given org to the same app server behind the scenes. We've gotten away from that and we're back to a fully egalitarian, perfectly load balanced round robin system. And that's a good scalable way to go. The database has state. The app servers tend to be pretty stateless.
So did you ever have to migrate a customer from one pod to other?
Yeah, occasionally we've gotten into trouble where a pod got really hot, and we do have code that can move it. It's not the prettiest code in the world, but we can do it. We probably could get better at it. We also, there's like a historical quirk where our very first database used the non-UTF-8 character set, and so we had to move some customers to the UTF-8 ones, but details. We don't do it very often.
So you use some heuristics to assign a new customer to a particular pod?
I wish we were that smart. We basically, we open up a brand new pod and we say, okay, everybody sign up there. And then it starts to get full and we say, okay, everybody sign up here now.
So some threshold you use when you deploy a new pod?
Yeah, and then once a pod gets kind of full, we just sort of detach it, no new signups there, and then we just let it grow. And basically we, excuse me, hardware gets better at about the rate that the customers grow. And our pods are bigger now, but we've gotten smarter. And the hardware's gotten faster.
So they're not running the same hardware underneath every new gen.
We tend to upgrade relatively aggressively, but yeah, at any given time, not every app server is the same. But like, we just refreshed all of our app servers with these nice Nehalem servers that are super fast, and in a year from now, it'll be slow again. We'll get new ones. Okay, now you're the last question.
One more nasty question on my mind. What's the future look like with Microsoft? Salesforce. What is that? How does it work divide? Or does it?
I don't even know how to answer that one. I mean, they're coming around to a lot of this cloud stuff, and good for them, and maybe they'll be really good at it, and maybe they won't, but we've been doing it for a long time, and we've learned a lot. We have a lot of scars and a lot of experience. Now, they're a lot bigger, so good luck with them, but you know, there's room for lots of people.
So you do see a room for standalone software?
Yeah, it's not like everything's going to change over over one night, or even over a decade. But I don't think it's that controversial statement that cloud computing is growing, and it's probably on a good trajectory. And a lot of it, we were kind of the proving ground. People, when I started, there was still a lot of skepticism about giving us their data and running their business, but we've been pretty good stewards. And our CEO, Mark, sees himself as the vanguard of this whole movement. So we've done a pretty good job. We have to be diligent and vigilant, but we've been pretty good stewards. All right, well, let's call it a night.
That has to be it. Well, I want to thank Craig for taking time out of his schedule.